Hello everyone, and welcome back to this last video of my Proxxon MF70 CNC conversion. I've managed to put together all the files and publish them on Thingiverse, so I thought I would make this quick video to wrap things up. I will go through the main concepts behind this build and also try to address some of the other aspects of my CNC experience. The main idea of this conversion was to use the stepper motor as the fixed point of each axis and get rid of any intermediary bearings, flexible couplings, etc. Like many CNC conversions out there, this one uses the popular NEMA 17 stepper motor. So we'll start with the motor, which has been the recipient of the first modification, which, although small, is critical to this project. The idea is to take up the slack inside the motor so it can function as the fixed point of the axis without adding to the backlash of the system. You will first have to remove the wave washer inside the motor, measure the play, and print the adjustment ring to the correct height. For this you can use the scaling function in your slicer. In my case, the play was different for each of the three motors, so be careful. Do them one by one, ideally. The coupling between the motor and the lead screw is made rigidly using this 3D printed coupler. The original lead screw is not particularly straight, so you will need to fix the wobble as best as you can. I think a small amount of movement can be tolerated by the system, so don't worry too much about this one. The bridge part of each axis is just that, a link between the motor and the milling machine. The motor is mounted first onto a plate, then to the bridge that you just saw before. This part is the same for all three axes. I used M3 socket screws to assemble this part. I know some purists will say that you shouldn't use machine screws directly into plastic, but it works just fine in this application. If you have trust issues, you can use wood screws, which will definitely hold better. But make sure to use the ones which sit flat and not the conical type. Now, at this point, you could stop here and this would make a fully functional conversion. If you want to take it a step further, you can replace the original plastic nuts, which in my opinion are the source of some of the backlash in the original machine, with 3D printed ones. You will have to tap the passage for the lead screw yourself. The Z and Y axis take left-handed lead screws, so you will have to get this particular tap. For the Z axis, the 3D printed nut screws directly onto the milling head. For the X and Y axis, on the other hand, this requires you to make a cut in your original carriage, which is a bit irreversible. Since the last video, I also created a stencil to make this step a bit easier. It goes on top of the carriage and locks onto the seat of the original nut. You can then mark the cuts to be made with a Sharpie. In my case, I drilled the holes around the perimeter, then used the Dremel with a cutting disc to finish the process. The X and Y cross nut is available in two sizes, for the original M6 lead screw or for the 8mm trapezoidal screw. I explained the advantages of a trapezoidal thread over the metric one in the second video. What else can I talk about? Electronics. Nothing too special here. I use an Arduino board with Gerbil and a CNC shield. For the past 2 years I used the A4988 drivers, but I've since upgraded to the TMC2208, which I run in legacy mode. The new drivers have made a real difference in the way the machine runs. Here's how it sounded with the original drivers. And here's how it sounds now. The currents were set to the same level between the two, and the force it exerts before skipping steps is the same. What else? I considered making provisions for some end stops, but omitted them in the final design. I never found them to be useful in the time I used this machine. This is not like a 3D printer which has its homing routine and the same origin on the bed every time. For milling operations, the origin of your paths are defined by your stock, so I can't say that I find the homing routine particularly useful. Maybe to stop the program in case you run out of trouble, but in my experience this has never been the case. When I crashed this machine, it was always either in the stock, if I didn't set the origin properly in CAD, or into fixtures. So end stops wouldn't have made any difference. Right, I think that about covers everything. If you have any questions, leave them in the comments. I'll try to answer as best as I can. Good luck and hope to see you soon for more upgrades to this machine and some actual cutting at some point.